so today we start our unit on work. So when we're talking about work, work is being done when an object has force that causes displacement. That means that it moves. So the equation that they gave us in the textbook was W equals FD, which remember your change in displacement is your X most of the time. F stands for force and W stands for work. Only when the components of the force are parallel with the displacement. In the book, it gave you an example on page 157. And what it was doing is it was actually showing you that somebody was trying to push a work being done on this crate is equal to the force times the displacement times the cosine of the angle between them. So what it's telling us here is since he was at a degree angle was 90 degrees, there was actually no work being done when he was looking at the crate. So when we're talking about work net equals force net times displacement cosine the angle. So the first thing I want us to look at is I want to look at the example problem that we have on the bottom of page 157. It says a girl playing the tug of war with her dog pulls the dog a distance of 8.0 meters by exerting a force at an angle of 18 degrees with a horizontal. At the amount of work the girl does on pulling the dog 190 joules was the magnitude of the force. So the first thing that we're going to look at here is we're going to look at our variables first. So the variables that we have is we have 190 south. Our displacement was 8.0 meters, and our angle was at 18 degrees. And they're wanting to know, okay, so what was our force? To be able to do that, we start with our equation that we have first, which is work equals force times displacement, but we're also going to do a cosine of the angle based on the drawing that we would have drawn. So based on that, since we are looking for the force here, we would take our work divided by our displacement cosine angle. So if you'll get your calculator and open it up on your computer, and let's see if we get the same answer as they do here. So the first thing we're going to do is we're going to look at our settings, because remember, our modes keep going in and out based on what we're doing. We will have to have it in degrees because this is an angle. So make sure you go down and change your calculator on your computer to degrees. And then the next thing we're going to do is, since this is a fraction, we're going to do alpha y equals. And when we do alpha y equals, that should give us the fraction. So the first thing we're going to do is put 190 on the top. We're going to go down to the bottom. We're going to open bracket 8.0. We're going to also do our cosine of our angle, which our angle was 18 degrees, correct?
Yes, ma'am.
Thank you. And so based on that, Bailey, what did you get on yours?
I cannot see what fractions on the board because of the glare.
I'm sorry, I'm doing on page 157, baby.
Okay. Let me pull up my book real quick.
And I think it's because my pen's about to go out too, so. So Bailey, you're going to do 190 over 8.0 cosine 18, please, ma'am.
I got 22.6.
Okay, so tell me what you put in your calc. First of all, did you change your calculator mode to degree?
Yes, ma'am.
Okay, so tell me what you put in.
I put in 190 over 8.0 times cosine 18.
And you got what?
22.6.
I got 24.97.
That's what I got. Did you make sure to put it in brackets?
Yes. Let me try again and see what happens.
Can you see my Bailey?
Okay, I didn't put my cosine 18 on the bottom. I multiplied the whole fraction by cosine 18.
Oh, okay. That makes sense, because I was like, what in the world is she doing? Are you good?
Yes, ma'am. I got 24.97 now.
Fantastic. Okay, so let's turn to page 158. So on 158, it says a car has run out of gas. Fortunately, there's a gas station nearby. You must exert a force of 715 newtons on the car in order for it to move. By the time it reaches the station, you have done 2.72 times 10 to the 4th joules of work. How far have you pushed the car? So what would probably be the best thing for us to know first?
What is the weight of a car?
Have you seen that before?
Yes, ma'am.
Okay, so that kind of gives us an information of what we need to be doing, right? It's that triangle that's just so easy to understand. So the first thing that we want to do is, Jordan, what is the force that we have here?
715.
715 newtons, right?
Yes, ma'am.
And then the work, what was our work number that we have here?
2.72 times 10 to the 4th joules of work.
Okay. And do we have an angle?
We do not.
Okay, let's put 0 for our angle because we don't know what that is. And what is our displacement?
Which page are we on, Miss Sloan?
I'm on page 158, baby. What is our displacement, Jordan? Do we know?
Not at this moment.
Yeah, because that's what we're looking for. So to be able to do that, we want to find displacement. So to find displacement, we're going to go in and we're going to say W over F cosine in our angle. That is the equation that we're going to do. So based on that, our work is 2.72 times 10 to the 45th power. We're going to divide that by 715 newtons. And then we're going to cosine this by an angle of 0. So let's put this in our calculator to see what we get. What did you get? What did you get, sir?
I got 38.04.
Yep. And that is our angle. Our answer is 38.04. And we are going to be using them in, since we're trying to find D, that would be in newtons, correct?
Oh.
Bailey, you okay?
Yes, ma'am.
Okay. Questions about that, because this here is an easy section. Are you ready for number 2, Bailey?
Yes, ma'am.
Okay. So number 2 says a weightlifter lifts a weight vertical distance of 2.0 meters. If a constant net force is 350 newtons is exerted on this weight, what is the net work done on this weight? So what do we have? What does our 2.00 meters stand for?
Would that be the displacement?
That would be displacement, yes, sir. And then our 350 newtons, what is that going to be?
Is that our force?
What's that, Bailey?
Is that our force?
Yep, that's going to be our work. Very good. So we are looking for force though, aren't we? Because we know that if we look at this equation, it tells us he has a constant net force of 350 newtons, but it's asking us for the net work done. So if we're trying to find the force of his net work, what would be our equation or formula that we would do? We do our force net.
So 350 minus.
Our angle. Rice, I'm sorry, honey, you were telling me, wasn't you? Jordan? Okay. So Jordan, what are you plugging in here?
So you have to do 350 minus 2.0, right? I believe so.
Okay. So what are we doing? We're doing 350 newtons times our 2.0, but we're going to do our cosine, our angle. What is our angle? He's going straight up and down, correct? So that would be also 0. So plug that into yours. Hey, Abby. Tell me what you get. Abby, right now we're on page 158 on question number 2, baby.
Would it be 700?
Yeah, I did. I got 700, and 700 is good, or you can do 7.0 times 10 to the second newtons, either one. Bailey, did you get that answer?
I think I put something there wrong because my number's really weird. It's like 25,000.
Okay. So what did you put in your calculator, baby?
I put two. I put my cosine on top and then the 3. Okay, yeah, I got that all mixed up. Let's try this again.
Okay, so you're gonna do your force net, you're gonna do your work first, which is 350 newtons, right?
Yes, ma'am.
Times your displacement, which is 2.0, cosine your angle, which is 0. If it's not moving in an angle and it doesn't give us an angle, we're going to say the angle is nothing right now.
I got 700.
You got 300?
700. Are we multiplying everything together?
Yes, ma'am, we are.
Okay. 350 times 2.00 times cosine of 0.
No,
Yeah.
that cosine is 0. There's no angle.
Oh, okay.
You're trying to do the weight again. You don't do that.
So we just. Yeah, I'm lost.
You can do it. You got this.
No, I'm lost. I'm just confusing myself more.
I'm trying to turn you up because I can barely hear you. All right, Bailey, can you see my calculator?
Yes, ma'am, that's what I did.
Okay, so where are you getting confused? Is it just too easy for you and you're thinking it's harder than what it is? Where you are confused about what you're trying to find?
I just felt like 700 was a really big number and I didn't really know what that was supposed to be.
So what we're trying to find here is we're trying to find D, the displacement. So if you think of what the question's talking about, the question's talking about a guy, right?
Yes, ma'am.
Lifting weights, right? Straight up and down. And it's asking us what the displacement was. Now, that can be in meters. So how high was he if it's 7.10 to the second power, how high is that?
7.10 to the second power?
If you want to change it,
50.41.
if you want to change it to scientific notation and you hit second enter, you get 7E2.
Okay.
Does that make it easier for you to understand?
Yes,
Seven, is that better? Because I know the 600 is throwing you off, isn't it? I mean, the 700 is
that
throwing you off, isn't it?
700 just seemed weird to think about someone lifting a weight and moving 700.
Yes, ma'am. Is that better?
Yes, ma'am. I'm good now. Scientific notation just makes it seem.
Well, no, honey. Listen, and the thing about it is if you look, and if we're doing it, and it doesn't make sense to you, it's fine to ask the question. Abby, are you on page 158? Are you ready for number 3?
No, ma'am, I'm not. I'm still on 1 and 2.
Ma'am?
I'm still on 1 and 2.
Okay. Well, only thing I'm going to do is just ask you the variables. Can you do that for me?
Yes, ma'am.
Good. So it says a shopper is in the supermarket pushing a cart with a force of 35 newtons directed at an angle of 25 downward from the horizontal. Find the work done by the shopper on the cart. The shopper moves along a 50-meter length of aisle. You got it?
Yes, ma'am.
So the first thing I want to ask you is, what is the force that you think from this word problem?
35.
Yes, ma'am. So my force is 35 newtons. Very good. What is my angle?
25.
25. Thank you. And then what is my displacement?
50.
Yep. 50 meters, correct? And we're trying to find work being done on this problem. So the first thing we do when we read our equation is we just write down the information that we know. We know that work equals force times displacement, cosine, or angle. So since we're looking for work, we don't even have to change this equation. So the only thing we have to do here is we say, all right, 35 newtons times 50 meters, cosine, and then our cosine is 25. So Abby, can you put that in your calculator and tell me what you get?
I got a really big number.
Okay, so why don't you do this? Why don't you do your mode and change it to scientific notation, please, ma'am?
1.6
Yes, times what?
times 10 to the
Third power, right? That's what that E and the 3 at the end is. Is that what you got?
Yes, ma'am.
Yeah, that's it. That's the answer. So the answer was 1.586038627, and we're going to round it up to 1.6 based on sig figs times 10 to the third. And that is what the work was being done. Now, if we're doing work, what units are we going to use?
Joules.
Yes, thank you. Questions so far? Okay, so let's look at number 4. And what I'm going to do is I'm going to wait a few minutes, and I'm going to give you a couple minutes to look that over to see if you can figure out what the answer is. Where's Hayden at today?
Not sure.
I ain't either. So number 4 says, if 2.0 joules work is done to raising a 180 gram apple, how far is it lifted? So what we've done so far is we've used this, which is our displacement equals work divided by our force, cosine, or angle. But I want to introduce a new equation to you today. So this one is displacement is work divided by mass times gravity cosine angle. This is the one you're going to use for this equation. The reason why we're using this one for is because what is this apple doing?
It's raising or rising up.
It's raising. So since it's raising, is my gravity going to be a positive or negative?
Positive.
Positive.
If it's raising, is my acceleration of that going to be positive or negative?
Positive.
You were right. It's positive. Thank you, ma'am. So we got 2.0 joules, right? Our mass is 180 grams. Gravity is 9.81 meters per second squared. And our cosine, what is our angle? Doesn't give us one, so it has to be 0. Because it's not to the left, north, east, west, it's straight up and down. So alpha y, enter to get our fraction. 2.0, slide over to the bottom, open your bracket to 180, open a bracket to 9.81, and then your cosine, your angle is 0, close your bracket, slide over and hit enter, and what do you get?
1.13 times 10 to the negative third power.
Yes, please. 1.13 times 10 to the negative third power. And that is our answer. Bailey, are you able to see the blue better than the black or not?
Yes, ma'am.
There's one other thing. I'm sorry, baby, go ahead.
I said yes, ma'am. I am.
There's one other thing that I want you to write down, and I'm gonna tell you what it's gonna say, but I'm gonna write it down also. The last part, after you did the word problems, then it started talking about positive and negative forces. And that's on the bottom of work on page 158. So on 158, it was telling you about negative work. Let me give you these numbers. And positive work. So what it was telling us here is it gave us a diagram of the distance of the car that was going and a person applying a force. We also had this. And if you'll just copy what you see in your book. So if you look at the very first one with the negative work, it shows someone's car, a winding car, that is going in the right direction. The problem is there is a man that has a tension rope that is keeping the car from going where it needs to go. That is considered negative work. Also, they have the car, the wind-up car going, and then they have a man with his hand holding the car back. Both of these scenarios are negative work. Then also it talks about where you have a winding car going and a man has the rope this time in front of the car and help pulling the car along. And then here has it where it actually is going along and then he's behind it pushing it, making it accelerate faster. Those are some of the things I want to make sure you have in your notes. The other thing that I want you to do is put down cosine of an angle that is negative. In other words, greater than 90. And then if it's less than that, so at the, I think it was at the right-hand side, there it is. So at the very last sentence on page 158, it says, if you're very careful in applying the equations for work, your answers will be correct sign. Cosine is negative if the angle is greater than 90. So when it's greater than 90, that means that we have a cosine is going to be negative, okay? If it is less than 120, but it has to be less than 120. I mean 270. God, I can't read my own writing. So make sure that you put that in your notes and highlight that because that's going to be important. One other thing that I wanted to add was these scenarios. So if the force is in the direction of the motion, okay? So if you're, sorry guys, I'm running out of markers. If your force in direction of the motion, that's going to be positive work. So the force is in the direction of the motion. Example of that would have been this one right here, right? Same thing with here. If the force is in opposite motion, then that one is negative work. If the force is 90 degrees to the motion, there is no work being done. That force in 90 degree to motion was that box that was being slid across the floor. That was at a 90 degree angle, and based on that, there's no work, because remember what work is definition by, is it has to change displacement. And then the last one, object is not in motion. Do you think that's work or no work?
If it's not in motion, wouldn't it be no work?
No work. Perfect. Thank you, baby. And that's it today. That's all it was. What it was is this section was just talking about work, number one, talking about, remember the triangle on where everything's supposed to be, because you'll have to rearrange that triangle to change the variable. They're the easiest ones to change. You will need to make sure that you understand if it doesn't give you an angle, the cosine is always 0 unless it states that. And then you will need to know these here, what negative work is, what positive work is, and what no work is. If you know those scenarios, you're not going to have a problem with telling me if something is work or not work. Questions on this section?
No.
Questions on the tests? Did everybody finish it? Or Jordan, you working on it now, baby?
I actually finished it last night, and
Cool.
I turned it in.
All right, sounds good. This is all for the day. Do you have questions? Because it's a really quick one, because it's not even 3 o'clock yet. May I suggest to you, for the extra 15 minutes that you have, go ahead and go into the next section and start looking at that. I am going to give you a paper. I'm going to make a copy of this paper here. And this is that coordinate system thing, Abby, that I told you I was going to get you. And so what I'm going to do is I'm going to take a picture of that and put it in there today. to help you figure out if it's sine or it's cosine, is it tangent, what if it's negative or positive. So I'll take that picture and put that in there today because we will need that to know that tomorrow for the coordinate systems. Any other questions?
That'll be it.
Bailey, you okay, baby? I'm sorry I started off rough. I got to figure out how in the world, and I'm hoping tomorrow I'm going to give me some new markers and maybe that'll help because I put this thing up here trying to keep the glare from coming off, but does it making it worse?
I don't think it's worse. I was just confused at first because I joined a little late and then I couldn't get that one question.
Oh, okay, I got you. Either that or maybe what I will try to do tomorrow is maybe use the projection and try to use the pins if I can try that maybe. But this just don't overthink these questions because this section was very, very simple. Everybody good?
Yes, ma'am.
Fantastic. Love you guys and I'll see you tomorrow, okay?
See you tomorrow.
See you tomorrow.
All right, honey. Bye.